Good afternoon, everyone. Welcome to the sixth Enterprise Innovation Broadcast. I'm Matthew O'Keefe from Oracle Corporation, and I have several very smart enterprise architects and engineers with me, Randy Olinger and Tom Hudak. They're my regular guests. We really appreciate you joining today. The topic today is enterprise software innovation and just what's the future of enterprise software development. There's things like microservices are popular. Monoliths have been the workhorse for years, and who knows? There's the next hot thing that's coming around, maybe low code. So there's a lot of things going on, and big enterprises, as usual, have a lot of demands and requirements, a lot of moving parts, and in the meantime, folks like Randy and Tom are trying to keep things operating at the same time trying to add new capabilities. So really, that's really the future or the topic today is where that's going. So Randy and I and Tom spent some time talking about what we're going to do in the show, and I think the first thing is we wanted to talk about is really who's driving decisions now with how software development is done, which languages you pick, which framework, where it runs in cloud versus on-prem, or maybe something like both. So maybe let's open it up that way, and maybe start with Tom. Where is that decision making? Is it all with developers? Is it CIOs? Is it some kind of business owner? What does that look like today?
I feel like a lot of times it's like it depends on where you are in the life cycle of something, right? If you're starting new, the developers might get to basically pick right from the get go what they want to do, what stack, tools, processes they want to follow. If you're picking up on a legacy product, you might be sort of pigeonholed into whatever it was at the time, right?
Yeah.
But in the event that you're greenfielding something new, I think generally I have not found too often that it's highly specified. I mean, they might have a preference for Java, or you might have an obvious performance need for something like C or C++ in your language space. But generally, as long as you can get from point A, which is requirements that are defined, to point B, which is the service is running and the business can use it to make money or interconnect with another thing or provide something of value to somebody. How that happens, I haven't seen it be too prescriptive from the top down, right? It seems to be very developer centric, but it leads to a lot of fraction in different solutions that do the same thing, right? So you
Mhm.
get 8 different tools that all can do the same thing. You might get eight different teams using each of those different tools. Outcome is the same. Your software builds, it releases, it deploys, it gets tested. Some tools are better than others, but yeah, you get a lot of, then end up with these camps, right? And that can be the really tricky part, is you don't want to have too many different versions of the same basic process. You lose the ability to gain compounding value, repeatability from having too many of the um, same solution.
Mhm.
If you get 6 or 8 different CI/CD pipeline tools and they all do the same thing, you know, that's not necessarily to say one is the right solution either. You don't want to have all your eggs in one basket, but
Mhm. So it's kind of a balance of having maybe a standard, but alternatives as well.
yeah, I mean, probably, two is better than one, but 10 is not better than two necessarily.
Hmm. Yep.
Yeah, I think when it comes to things like languages, it's kind of dealer's choice. I mean, just about all the languages, the modern languages that we use today, Node and Python and Java, JavaScript, there's bindings for the APIs for all of those. And as long as you can intercommunicate between different layers of different applications, the language isn't as important as it used to be. But when it comes down to the underlying frameworks or the underlying, I guess I'm thinking of the the plumbing, the architecture around the plumbing of how data works its way through an organization. I
Hmm.
think more centralized architecture is becoming more common. Companies like Netflix, companies like Google have come forward and said, look, we're building our platforms around one single way of doing things, and that will evolve, but we're not going to allow 3 or 4 different ways
Like
to
Netflix, like
do
Google,
messaging, for
have
instance.
come forward.
So, a company that grew organically might have 5 different messaging platforms, and trying to support them all completely inoperable or not interoperable, and very little skill sharing or personnel sharing between teams, where that's a huge inefficiency. But
Mhm.
whether or not people send their messages and read their messages using Python or Java doesn't really have that big of an influence. One of the things you're looking for is mobility in your workforce. So when the way IT tends to wax and wane as projects come and go, and different businesses in a large organization have different needs at different times. So you want to be able to move resources around without having to hire and fire all the time, because there's huge training costs. So,
Right.
having somewhat of an opinionated view of your tool set at the lower level, lower than the programming, but more the architectural or physical layer, is I think very necessary.
Mm-hmm.
And Tom hit on that too. You don't want to have 5 copies of the same thing of a CI/CD pipeline, for instance, but
Right.
one isn't necessarily always the answer. So, it's okay to have some people that use old school Jenkins and some people that use Microsoft's
Mm-hmm.
tool set, which evades me right now. They have one.
Yeah.
Team Foundation Services.
Yeah.
So-
They all work out. The other thing is we get caught in this belief that there's a choice and one of them is right, so the other must be wrong, and that's a bullshit discrimination that technologists often fall into.
Found a lot of false binaries out there in the landscape.
If you're really spending all your time debating between one that's 95% good and one that's 96% good, you're not getting the most for your money out of your high level architects.
So who's making those decisions, though? I mean, is these days there's a lot of discussion of developers obviously have a lot of influence. They're very really good developers are in short supply, and so they obviously have a lot of influence, and obviously they should. They the tool sets they use or maybe are good at will drive efficiency. On the other side, there's corporate standards, and then there's the business project owner might have their favorites, or they might need to integrate with with a larger piece of the puzzle within, help maybe they're webifying something, but it's a mainframe application at heart. So what are you seeing, not only in your own shop, but kind of what are you guys seeing with respect to how that balance is being made?
Well, like Tom said, Greenfield, there's a lot more flexibility. I've seen it happen where we hired a very strong, opinionated developer who's got some good experience in this particular technology, and that becomes the technology used for that project. Or they have like a blast radius around them too. It might become the desired standard for everything around them, which is okay, right? As long as it's not a really terrible decision.
So in that case, it's just strictly
decentralized architecture committees and things like that, and that just bogs down innovation too much. I think some of our areas at this large organization still have those, but the reality is they are kind of dismissed. If someone really wants to use a technology, as long as it's not too far off the accepted list, they do it. And and honestly, if it's open source and got a good community around it, there shouldn't be a lot of pushback on it.
Yeah,
we have a list. Our company made a list of preferred and acceptable and deprecated or discouraged and absolutely undesirables. So we categorize and such. But the reality is, each team, for varieties of reasons, all of which you mentioned, makes a decision in real time when it's needed.
Mm-hmm. Okay.
Not all the leaders that. Not everybody rolls up to the same leader. Not every leader who eventually does lead all these leaders cares enough to go down that rabbit hole and make all those individualized decisions for each group, right? So you end up with teams with leadership who want a different approach or different strategy.
Right.
I mean, ultimately, it's contextual, and it's typically the best solution wins out. It's not always that way, but if you can get
or it lasts forever and you kick yourself, 5 years down the road, you're saying,
get away from it. What did I do? But those things tend to have like a gravity around them, right?
Yeah.
So if you build a really good platform or a really good process, people will get behind it because they'll naturally start using it. It's becoming more and more rare for overly prescribed process to be the thing that gains the gravity and the attention of the mass of people that are going to use it.
Where I find when I get pulled into those decision processes, where I focus is there are some things that you're marrying and some things you're dating. We used to joke about.
Yeah.
And anything that stores your data, you're married to it. You know, your
Yeah.
database, your Kafka system, your storage layer, your network storage, whatever.
Yeah.
That stuff you're going to have a very difficult time swapping out later on. It's very difficult, regardless of what the vendors will tell you.
Sure.
But when it comes to logic, you know, whether you got a rules engine, say, well, okay, you could a lot of times pull one out and put another one in. It's not slam dunk, but it's a lot easier than changing out your data systems.
Yeah, absolutely. And you know, as it being somebody at Oracle, it's like, yeah, it's the database is sticky, file systems are sticky.
There's a reason they call it a data center.
It's persistent.
Not a program center,
It's
an
persistent.
application center.
That's right. It persists. So so based on what Tom was saying, like, you know, you pick something and then you hope it's the right thing. Let's talk about the influence of just maybe what we call like fashion, right? So Larry Ellison once said that, you know, the tech industry is more fad driven than the fashion industry. And you know, there are, you know, all of us are old enough to have seen, you know, certain things come along and they seem to be like they're going to be the greatest, you know, they're going to solve all our problems, be it object-oriented programming or fourth generation languages, et cetera, et cetera. Now they've all added to the, you know, they all added something positive to the mix, but they weren't the silver bullet. And
Blockchain.
You know, how dare you say that about my beloved Perl?
Where else to go?
That's
We
right.
could sit and make jokes about it for an hour, probably.
Well, it's funny, like the guy who wrote the classic book on software engineering, which was the Mythical Man Month. I forget his name, but anyway, brilliant dude. So, you know, bottom line is back in the 60s, they didn't really know nobody had really figured out the laws of software engineering.
Mm-hmm.
And, you know, he was the guy that basically said, you know, if you add more programmers to a late project, it's going to get later because then the programmers end up talking to each other rather than programming. And you can't. So, I mean, yeah.
9 pregnant women don't make a baby in a month, right?
Yeah. I still recommend that book to every young intern that we
hire. It's
timeless.
Yeah.
It gives them a sense of history, too, of what life was like. Not that most young people really care about the old man by the fire talking about how hard it was to program language in the snow. But it is a great read. Kind of like what's the other one? The Soul of a New Machine. A little bit of time at like 1979 time frame. Yeah. But again, a journalist writing about a hardware project, a general data, or no? Can't remember that.
That was required reading in my undergrad when I was undergrad computer engineering. Yeah, and there's a law, I think it's Conway's law, which says that a design will reflects the structure of the organization. And that's exactly what the Soul of the Machine was, right? So the
organization's a mess, the design will be a mess.
Yeah. So, getting back to the fashion show, technology, since then, right? We've fast forward 40 years and it's a crazy fashion show and the cycle time is getting shorter.
Yeah.
Especially with the new technologies that are going in the cloud. If you look at Amazon and Azure and Google and Oracle clouds, they are pulling in new features and services or resources every single day that, are quite honestly fantastic. But it gives you more ability to make more choices and it complicates everything a lot more too.
Yeah. Well, it's interesting. AWS, I've known several of their engineering managers and their design philosophy is to kind of make the services independent. And so and that actually helps you can scale it more easily. So you can develop more services that, there's obviously interfaces and all that, but there's no real underlying overall architecture. And I think
opposite of Azure, everything stacks on top of everything else. It seems which is good.
Right.
So, you buy some integrated service underneath, might be a Cosmos database or a very bespoke instance like an Event Hub, which is their instantiation of Kafka. But I don't know. I think I've seen some things at AWS like Athena, for instance, which kind of sits on top of S3 and some structured data. And I think it has this other module that interprets the structure of Parquet files. I don't know. It's kind of technical and I'm not an expert in it. Yeah. But I think there's a little more stacking than people might lead you to believe at AWS.
Yeah. So, my point about the Mythical Man Month was, and the fellow that wrote that is he kind of wrote a second. I don't know. I don't think it was a book, but it was basically an article. It didn't quite get as much. What the word is. It wasn't. It isn't as well known. But his basic argument was this: is there's essentially no silver bullet with software. That basically it's ultimately.
It's not like building a bridge. You can't just get more riveters in to get the bridge done faster.
Yeah,
which was essential. He also, there's some other things in Mythical Man Month that often get overlooked, was really define the structure of the team, and he said teams shouldn't get too big, which later on became the 2 pizza rule, which, you never have a team bigger than what can be fed by 2 pizzas, which depending on the people, you never know. But point being is he actually went in the Mythical Man Month and said, well, here's the different personnel or personas you need on the team. You need guys who's your tool master, and you need someone who's your hardcore programmer. You need someone who's your data analyst. You need someone who's essentially your nanny or your nag. He didn't call it that, but anyway, point being is really laid the groundwork for a lot of what we see in the agile world today. I think is very much reflected in some of those early writings.
Yeah. No, I agree, and I think ultimately the limitation is really complexity. So in other words, even if you give people as you're pointing out, Randy, here's some more, here's more cloud services, here's more capabilities. What limits what you can do is, and how long it takes is really the complexity of, of putting those pieces together. And that just really doesn't change across. I mean, there's certainly frameworks and where areas you can clearly improve. I mean, low code is obviously, if your particular application fits the paradigm of a particular low code tool, you'll probably be able to develop it really, really rapidly. So definitely there's some automation and libraries and reuse, et cetera, that help. But, fundamentally it's still, hard. It's basically a hard problem. No silver bullets. And that's kind of the thing that concerns me about as people make judgments and, making decisions and how to make calls and what to, where to put resources is how do you, in this sort of, busy world of, should it be microservice? Should it be a monolith? Should it be some other, should it be low code? I guess what I'm hearing from you guys is it's a lot of distributed decision making. And so the hope maybe is that it's distributed and the best, may the best approach ultimately win. Or what is there a strategy, or is there just is there reactivity?
I think the strongest persons or personality wins, right?
Yeah.
I mean, that's also
the hippo, also the highest paid person in the organization can have a strong influence. But the reality is I want a much bigger sample set than the two of us, because we're statistically too close in our organizations to give you a wide variety to answer that question properly. I'm sure there are plenty of companies that have, that still have very strong architectural teams and really try to limit the complexity in terms of diversity of technologies and things like that. And, I think there's good in that too. It's a difficult, it's like walking the edge of a razor blade,
Yeah.
Too much of one and you end up with a stodgy organization that can't make a decision. Too much of the other and you end up with a free-for-all. That's really fun to work at, but gets nothing done.
Right.
I think one thing that tends to happen is the relationship between teams and the things that teams can work on isn't well understood, right? So you can have one team can work on many things. The bigger those things become and part of a larger solution, the closer to one team to one thing you're going to get. But rarely do you ever want 10 teams working on one thing, right? It creates chaos. So that sort of naturally limits how big a team can be and how many, and then it guides how many teams you're going to need to build something of varying complexity, right? So without understanding that relationship, I think a lot of times you either end up with like really, really big teams where it's not clear who's responsible for what. And how to deliver those things together, or you overwork teams that there are too few of them for the number of components, right? And so instead of working down to having one team working on one thing as your absolute bottom, you're constantly trying to get one team to work on 6 or 7 different things at a time when they just don't. There's not time or maybe skill, right? And so, the more complex the thing you're building is not necessarily solved by more people individually, right?
You know, it's a great measure is if you're using, GitHub or GitLab or one of the Git type repository systems, how many conflicts do you have when you do merges? You're going to have them. Sometimes two people get into the same thing, and the systems are built to handle that. But you have to go deal with it, and it's a pain. So
it's almost like the raw error rate of development, right?
If you have a lot of GitHub conflicts, then that might be an indication that you might have literally too many teams working in parallel on the same thing.
Yeah, but I thought part of the microservice argument was that you could, if you use a microservice approach, then the design would kind of magically fall into, split into independent microservices.
It should, but teams don't always fall across the same boundaries that the microservices fall across.
Right.
That's the other.
If you got enough an organization, you can, like Tom was saying, one team to one microservice. God bless you. Go ahead. But those don't exist.
Yeah.
Big companies.
Well, I think that's the goal, though, right? Isn't it? If you talk to the proponents of microservices, it was
isolate and decentralize.
Yeah, you isolate and decentralize,
especially with data, right?
I'm sorry.
Especially with data, I think one of the big unhidden, unspoken challenges of microservice design, and it's called out. I don't remember which one it is, like it's number 8 or something. But you treat your data as a service that you're dependent on, but you're not bound to, right? So your app isn't holding the data. Your app is talking to something else that's responsible for holding the data.
Yeah.
And that very simple concept of separating the data from the app all of a sudden enables all these other things. The ability to split the domains of one application that might have too much functionality into separate ones, make it more scalable, but it does come with certain challenges, right?
Yeah.
If data is not in memory until network Ethernet is as fast as a memory bus, you're going to have a performance challenge.
Well, the other thing is, what about analytics, right, and reporting? Because typically, when you do analytics and reporting, you're accessing everything. So if you wrote your microservice in a garbage collected language, you're kind of running through. You're pulling in your whole service.
Your whole world.
Yeah. The other thing is kind of like, okay, so like obviously I mentioned biases. So obviously I'm at a database company, so I'm biased towards databases. But the problem with part of the thing with microservices architecture when they designed it is that persistence was almost like an afterthought. It's like, well, it'll just be another container that comes and goes or whatnot, but it's really ultimately a service, right?
It's a service,
yeah. And so, like I said, not to get commercial here, but basically, our suggestion is, hey, just deploy, virtual databases for each particular microservice. And if the other microservices really want to directly access the database and make queries, a lot of databases like ours have concurrency control and all the usual sort of transactions, et cetera, that people have been used to. Because I think,
you really don't want to. I don't know. Maybe I'm old school, but I just understand that that's really not what you want to do. The access to data should go through the service that controls it. Because when someone reaches around and goes for the actual tables in a relational database anyway, or really any, if that underlying representation of the data changes, now you've got the spiderweb effect of how many. If I want to go change the way I've represented the data to make my microservice better, it's not just me I have to worry about. I got to figure out who all these other Yahoos are that went around me into my data. So,
but you do anyway, right? Because your API has to get.
Well, your API, you can change the underlying structure of your data without changing your API. Your kind of contract on the API, if you can. But you're right. If you mutate your API, then you have to do the same kind of impact analysis and find out, who's going to have to adopt it. But you can version APIs a lot easier than you can version, schemas.
Data.
So.
It's getting better on the data side, but a version of a data sort of inherently represents some sort of a duplication or another set of it, whether it's altered or whatever.
I remember the old days when you used to do database design and then build your application on top of it. And nowadays you just build your application and use SQL Alchemy to create your tables and then just mutate it as you go. And it's really great from a programming standpoint.
Yeah.
Make some really bad database designs,
Mm-hmm.
And it's
Well,
very difficult so if you have a super scalable thing, I don't think that's the right way to go. If you have a tiny little product with, 15 concurrent users, you're probably gonna be okay in a small database. So when we get into like analytics and data warehousing and such, those schema generators or object relational models and stuff, they're great, but I think they can also paint you into a corner from a
mhm.
scalability point of view.
There are some capabilities in some SQL databases where you effectively you have essentially multiple versions, and you basically, as you have a modified sort of a new schema that you've modified,
You
and
can
then
change,
you have
mutate
triggers that can kind of keep them consistent. And
the.
so as your say your old microservice or your current microservice that hasn't adjusted to the new schema can keep using the old one until it's ready to move over to the next one.
And that presents yet another challenge, right? So we're all familiar with versioning of apps.
Yeah.
Right. We've all felt the pain of the new version of the app changes the schema of the database and it's not compatible with the old one. So you got to run some update and you got to reprovision schema or change your data. Right. But the idea of having an app version to a database version where that database service is running multiple versions of that data set, just like an app or an API runs multiple versions of the resource in that API is capable of using, right? Now you have to track those things together, and that's yet another logistical challenge that needs to be thought about beforehand. How are you going to track version compatibility between the version of your app, the version of the database? How are you going to roll those things together at the same time, right? And make sure that they're and that delves into a whole other DevOps topic that's even more complicated, which is the whole concept of deployment and delivery, right? It's all well and good to design these databases and design these apps. If you have to keep it up all the time, if your expectation for the business or the service availability is 5 nines, right, then that limits your window or your opportunity to roll out a new version or break something, right? And we're all, I think some of us are familiar with error budgets and things like that, SLOs and SLAs that you're required to, you're contractually obligated to maintain. But how you do those things, it's a very complicated web of tying all of these systems together to make a release go smoothly when you have different versions of data that need to be online, different versions of the app that need to be online, different customers using different versions of those apps and data, all in real time, instead of like, the old way, which might be you installed the app and the data and the database in your data center and it wasn't serving it out to the world. You didn't have to run 25 versions. You had an upgrade day, right? And everything went down, you upgraded everything, and now you're running on the new version. That's not always the reality anymore.
Yeah, those days are gone.
Yep.
With the world of mobile apps, there's just a 24/7 expectation that is permeated to every mom and pop app out there. So makes it hard. So but it's not insurmountable. But that's a good point. The whole how do you do deployments and stuff seamlessly when you're mutating multiple things at the same time. That's a complexity. There's lots of tools in the tool belt, but it's still just darn hard. So
so I'd like to go back to something you said, Randy, which was that, and I'm not sure I agree with it, but maybe I don't understand your position. So in my mind, in sort of the microservices architecture, that the general principle is that, like you said, you don't share a data stores. You have, a microservice owns it, and then you write, there's an API that is provided to the rest of the microservices. And if a microservice needs, if a microservice is getting data from another microservice and it needs, say, different data, that API, there's some kind of API change involved. So I guess what you're arguing is that's a lot easier than having.
It's more elegant. I mean, when just in general, one of the ideas of microservices is to encapsulate the access to the data, so you don't have to worry about impacts when things change. So and maybe it's a philosophical choice people can make. I just happen to fall down on the side of, I guess it's more of an object-oriented approach. I mean, that's truly the absolute rule of object-oriented programming is you go through the accessors to get to the data of objects. You don't go to the underlying storage for the object, in RAM or something like that. I mean, even in C++, where you probably could figure out a way to do it, it's totally not cool. So I guess I just extend that microservices access to data down that same path along the 25-year ago C++ training I had. So maybe I'm just, old guy by the fire.
That's all right. So speaking of old guys, and so monoliths and microservices, for a while, microservices had kind of become like that was a hot thing. Netflix really went all in on it, and they obviously their various VPs and development leads were kind of made their careers on this. But it's interesting because you fast forward from sort of their time frame was like late, kind of 2010, give or take a few years, and then it took them a long time. It took a very long time to get that actually working. And then you fast forward to 2018 and beyond, and you started to hear some of the influencers, Kelsey Hightower and others who associate with Kubernetes said, hey, it's okay to do monoliths, and it's okay to make monoliths, to leverage them for certain decisions, or to have monoliths coexisting with microservices. And again, you guys work in a rather complex, large place with a lot of history in its app. So I'm assuming that you're seeing hybrid, that it's combinations of maybe microservices to support mobile, or say new more modern aspects to the underlying application, but that it's really ultimately a hybrid. And is that the future? Maybe some kind of combination of the two?
Maybe we'll call it macro services.
Yeah. Well, it's funny. I mean, the size of things, the scale of stuff that we do things at, I think, I think a lot of people would consider something that we would call a microservice to be a monolith, like truly giant things.
We really have a lot of desire to reuse data, for multiple purposes. And we want to reuse data. Microservices work better than, big elephant. I shouldn't say that because it sounds pejorative, but monolithic apps, which almost sounds pejorative too.
Yeah.
But anyway, if the data needs to be reused in multiple ways, the idea is you make an object and anyone can access it through the proper accessors, and you have understanding of where it came from, and how much you can trust the data, the product, stuff like that. In apps, it's like, app B wants to get data from app A, and they're both monoliths. So what do? You can say, well, app A will write a API that app B can call. Okay, that's fine. Or you can do file transfers at night. And, that's
or you could do things like Athena, or we call it Cloud SQL, or Oracle calls it Cloud SQL, where you have basically this query front end to stores of different types. And in fact,
you could use Kafka for that too. You could shove it into a Kafka queue or a topic, and then people can pop off there. But
I think
there are options. But you know what? I mean, if someone's doing that, it's almost like they're writing a microservice. I would argue at that point when you're starting to, use maybe not. I don't know. I think we'd be diving into semantics pretty deep there.
This is sort of it's still a means of abstracting and decentralizing the storage and the data from the application's ability to query it, right?
Yeah. We looked at the streaming thing as a way that we could help free the data from our monolithic apps to make it available in microservices. So basically, when a monolithic app updates its data store, rather than make it build an API, we ask it to just push it to a stream, and then everyone can subscribe to the stream.
Yeah.
Very simple, pretty cheap. The only downside is, bunch more storage and stuff to manage.
Right. But how do you reuse that, and how do you query it, and how do you build analytics around it?
Well, the streams are pretty they're pretty flexible. They can act as databases to some extent, meaning I'm looking for a certain piece of information about apples, and go find me all the apples in the stream. That's not a very efficient way to go, because streams are essentially linear, and you got to search from the beginning to the end if you want all the apples. The more common way is to subscribe to it. So when a new apple shows up, you say, I'm interested in apples. And then when, there might be 50 transactions, but only 2 of them are apples, you'll get those two apples in your software system, and you can go process them. But
Yeah.
that takes forethought. It takes planning.
Well, that's this balance between being denormalized and kind of NoSQL. So NoSQL is like, oh, well, building a schema and being denormalized is too much work and it's too rigid. So we're just going to go for it. And then the problem is that you end up at the back end, you can't even do the kind of reporting that you'd really like to do because and you end up writing code to try to maybe denormalize it in the back end. So my feeling is that there's no free lunch. Back to the mythical man month. It's sort of like,
I would agree with that.
It's more upfront work. There's no question. And by the way, you're probably going to screw it up because you probably aren't going to have all the attributes that you want. And
I think, and I can only say this in theory, not having seen it 100%, but the theory would be that by using a streaming architecture in the background, the trick is you don't know which of your data elements are going to be requested, tomorrow or the next day. Right. And the old way is the team would be constantly reacting to interrupts. Every time someone wants a new data element that you happen to own, you're pulled away to go write an API so that they can go get it, or you're pulled away to do another file transfer and throw another wad of gum on that big gumball. But if you build your app that just says, every time I have an update, I'm going to push it to the stream, you're kind of like, it's your get out of jail free. It's like, don't bug me. My app's in the stream. You can go pick it up there. Or my data's in the stream. You can go pick it up there. Mm-hmm. And once it's in the stream, you can write APIs around it too. So it's a platform technique we adopted we try to adopt a lot, and it just takes time to get there.
How's it?
I think ultimately it gives the kind of right balance between pre-planning or foresight mm-hmm. and being able to respond quickly, mm-hmm. have both APIs and real-time event handling.
So that's that's really, maybe that's the hot next. I mentioned like a next hot thing, and so that really, maybe we've got about another 20 minutes. And so that really does seem to be the direction, is events and data meshes, and we see a lot of interest in, like, we have some products like Golden Gate around it. We try to integrate with Kafka very, very closely. So how is that playing out? Where you're at, and maybe other companies that you see. Because that's clearly basically looks like it's the new standard. So how's that working out? Are people, is the adoption going well? Are people getting value from it? Are they still learning? Where are we at? Well,
Randy, you go first.
We're like, we open here.
It's a can of worms, Matt. It's a can of worms.
But it's working.
We're a hard-hitting show.
And it's never where you want it to be. But in general, it's paying off in many, many, many areas. It's just how many times you say, gosh, I wish I had the piece of data. I wish it was in the stream so I could go get it easily. And it's not. You got to go talk to the data owners and find out. Just everyone's got a map or a backlog that.
Same with schemas.
Working through. Yeah. So it's not we've been on the journey for a few years, and we're going to be on the journey for quite a few more. It's hopefully when we build new stuff, we build it in at the beginning, so we're not trying to retro it in at the end. But change data capture is a quick way to get there. Like I don't think Golden Gate not really a change data capture, but it might be thought of that way because it does replication and kind of intercepts the log. Mm-hmm. And I don't know.
It can do that. Yeah.
But there's some very good products out there that will do change data capture. So you grab the data off of them, and then you can push it into the queue, and it absolves the application from writing all those calls every time they do an update. You just steal it from the database in the back end. Right. Not a bad solution, but I would call it a stopgap or a transitional solution because you have zero control over what goes into the stream or out. It's just, kind of like everything from this table and everything from that table, and building a JSON object that might be built from 6 different tables. I don't think it's that easy. You just see, 6 different transactions go through the log file, which ends up in your stream, and then the person pulling has to kind of reassemble that into the event that happens.
Shifts where a bunch of the logic is performed.
Yeah, that's a good way.
And,
but not a bad way to get started, though.
And then, Tom, I think you were in a project where some of the objects in the particular data mesh you had were very large, and so then if I recall, maybe that was a different, but I know that I think in general, a performance is probably something you can buy or you can build, but I don't know, maybe not always.
I mean, there are definitely, it's funny. The laws of physics are still the stress limit on the engineering of any compute system, right? And so And we like to think of compute as like you can design around any problem you have, but really, seriously, there are fundamental limits that you cannot overcome, right?
Yeah.
I cannot make data over the wire. No matter how fast I can buy the fastest network cards or the fastest, equipment to get data from point A to point B, and it's still not as fast as the processor talking to the local memory bus,
Yeah.
which is faster than the processor talking to a remote memory bus, right?
Right.
So if I've got these delineations on speed, and now you start to talk about massive data sizes, right? I can only get data from here in my data center to here in the cloud so fast, and I can only get updates and changes to that data over there so fast. And if I want it in both places, I have to make a duplication of it to some degree, or suffer the consequence of the time it takes to go back to the original source, right? So it's funny that it fundamentally comes back to it's cap theorem 101. When you have some sort of a network partition, some way of isolating data from one space to the thing that wants it, you either can build and design for availability at the cost of consistency, or you design for consistency at the cost of availability. And there were some ways to tweak that. It's not, quite that black and white anymore, but it does represent a challenge, right? How do I manage tens of petabytes of data between multiple data centers so that I can take advantage of cloud processing here versus localized processing here as a hybrid solution when the same data set is involved?
Mhm.
Or, people like, I'll pick on microservices a little bit, right? Microservices are all well and great, except they're not always micro, right? You can have a microservice that in your lab or in your development platform requires a couple megabytes of memory. And when you go put that microservice into production in an enterprise setting with tens of petabytes of data behind it, those microservices might require hundreds of gigs of memory suddenly. That's no longer by definition a microservice. It's not very portable, right? It still takes time to load 100 gigs of data over a wire, or even from a local, say you're doing a cache, right? There's ways to account for these topological changes, but ultimately you got to move data around somehow if you want it to be available in multiple places or by multiple things. If you want high availability, if you want fault tolerance, if you want to not be limited to running just in Google or just in your data center or just at Microsoft or just in Amazon.
Right.
I had an interesting tweet the other day. A friend of mine posted a picture of Elon Musk's big rocket. It's got 24 engines or 35 engines or something on the first stage. Not a super rocket guy, but I thought it was interesting. And I think a lot of people look at a lot of engines like that and say, wow, think about the redundancy they have. That's so awesome. I asked the question of, what happens if one of them doesn't fire? Does it upset all the mechanics so the thing just tilts over and crashes, or can it shut off the other one? And I'm sure with the knowledge of SpaceX, they've figured this out. But the point being is that just having more of something doesn't necessarily make it better. If they're all dependent on each other, it actually makes it a lot worse. Yeah. And we see that kind of mistaken philosophy all the time in application and infrastructure design, as people just get more, but they don't realize that each one of those is a single point of failure for the whole system, and therefore the system is less available, not more.
Right. Well, that's the spooky thing about microservice, when there's a lot of obviously benefits to microservices, but I also think you have to really sit down and take a deep breath and say, okay, you get ready, because you have to deal with distributed fault.
The devil's always in the details, right? I mean, if you go look at the original post from Martin Fowler on microservices, the one hidden most difficult thing to achieve is tucked away towards the bottom of the essay, and it's fault tolerance. Almost as an afterthought, and you better make it fault tolerant. But what is that becomes the most important part, right? Yeah. Now your microservice design has to support some sort of high availability, not DR, not your ability to recover from a backup, but I can take this down over here, and the app and the service survive and persist.
Well, No, I'm sorry. Yeah, I agree 100%. And in fact, if you think about Netflix, it's like the perfect application, right? Because it's 99.999% read only. And so
Right.
when you're building distributed systems, read-only systems are awesome because it's primarily about the delivery. It's less about, keeping a lot of like reads and write transactions on the fly and keeping some, like what a relational database does, or hell, even a NoSQL database to a certain extent. So there's that. There's also just the fact that, okay, everything, I get it, APIs, but that means everything goes through the API, right? So
Right.
it's the network
Another
overhead.
layer, could be another bottleneck.
And I keep coming,
But
okay.
even Netflix, yes, delivering the movie is an immutable read-only operation, but that's like, I would bet if there's any Netflix engineers on the stream, I'd love to hear from you someday if I got this wrong. I would bet that's less than 50% of their technical problem, that the customer profile, the billing, the logistics, all the things that are more read-write transaction-y, their recommendation engines and all those things. I bet that's at least 50% of their technology budget. Maybe not budget, that's the wrong word, but their technology mind share, I'll call it that.
Mm-hmm.
Yeah, that's probably
right. Just because they're delivering jillions of bits over the wire, but that's easy, so they don't spend a lot of time on it.
Right.
Well, I actually did talk to Amazon's, competitor, their Prime Video folks once, and they actually, they actually spend a lot of time optimizing the path from, wherever the data is coming from to, your mobile device or your TV, and they have a lot of quite a bit of intelligence to try to make sure that part of the content.
Yeah, I believe that and I'm sure they use a content delivery network.
Yeah, and if you're right, Randy. Which is, there's 100. If you got 250 million customers, there's a lot of churn in terms of new ones and old ones and the updates.
And their video set. I don't know if you've ever noticed when you click on something that's a little obscure, it might take 10, 15 seconds to come up because they're kind of getting it out of the vault. Where you pull up Queen's Gambit and boom, it's 2 seconds and it's playing.
Well,
it's hot.
The other thing is, like, in my opinion, back to looking at alternative, something, this is my hobby horse, but basically looking at things as alternatives, not, what's the word? I must do it because it's the latest and greatest thing. And the thing is, Netflix took a long time to develop, that app. I mean, to go from their sort of physical to,
certainly in the early days, too, network capacity was a huge cost, right? I mean, just optimizing that was the difference between succeeding and not succeeding in their early days. But as with everything, the hardware's gotten better and better, including the interconnects. So the delivery, the last mile. I mean, I don't know anybody now that worries about their VPN going down when someone's streaming a movie, right? It's just a solved issue in America.
Right. Yep. Cool. So let's see. We've got about 10 minutes. Some of the things we talked about before the show in terms of, I think it was, like how our project started, and, is there, what is the process to define what the product, the software, product is going to do, and how does a business owner connect, work with the developers? And I think maybe it was you, Randy, but basically there's sort of you're saying that what you're seeing, at least maybe just in your company, but I think you're right about elsewhere, but build it and they will come. So you kind of put things together.
Well, there's two strategies. There's build the Field of Dreams model and the make a little, sell a little model. Mm-hmm. And when people talk lean software development, they're talking about the make a little, sell a little, and just kind of grow it organically. Mm-hmm. And the other 99.9% of the stuff I see, which I hate, is the Field of Dreams model, which is, the highest paid person in the room says, this is the way we're going to do it. We're going to make, rocket box ejectors, and we're going to sell rocket box ejectors. And everyone says, what's that? Shut up and go build it.
It's going to be the hottest thing this year.
Yeah. So it's
hula hoops.
And I think if someone has enough industry experience or domain knowledge, you might call it, to use a $5 word. You can build great apps that change the world. But without customer feedback early in the process, I've just seen too many of them go awry. They start off with these grand ideas, and then they throw a whole bunch more people at it, and they suffer the mythical mammoth problems, and they kind of lose their way. And by the time they get going, these projects, they don't get out of the gate because they price themselves out of the market.
Yeah. Well, the other thing that surprised me when you mentioned that sort of paradigm is that I asked you if were they involving an example customer, or did they have like who when they created the UI, did they show it to somebody to see if they were on the right path? And then I was a little surprised at your answer.
Well, I think, I don't want to make it sound like it never happens, but wireframes oftentimes get tossed around. If someone writes up a wireframe on a PowerPoint to just get a feel for it, and those are cool. There's nothing wrong with that.
Yeah.
But as the UI iterates, I don't know. It's dealer's choice there too. Sometimes people have a very close relationship with customers and get great feedback. Other times it's a domain expert that gives all the feedback. We've got oodles of people that have corporate standards and design policies and pick the right colors and tell us, what fonts to use and stuff, which is important, right? Branding, not to be I'm not trying to say we shouldn't have branding experts. It's a good UI, is not to be is something of is a thing of beauty. It's just a lot of work to get there.
Yeah.
But the projects get going. Oh, go ahead, Tom. Go ahead.
They're so personal, right? I mean, it's very hard to build a UI that suits everybody because people think about things differently, so they go to search for things differently, right? There's a whole human factors thing behind it. The people who design nuclear power plants design those plant control systems in such a way to account for the behavior of humans, so that a human can't create a failure just through their own actions, right?
Post 3 Mile Island, you mean? Or?
Yeah. And there's always room for improvement too, right?
We definitely learned the hard way on a couple of those, but
I don't know.
Yeah, it's why you have the QA idea of QA, right?
Don't hire Homer Simpson.
There's an old joke. A QA engineer walks into a bar and says, "Give me 0 beers. Give me 9,999 beers. Give me AQ pound for ZL beers."
Yeah.
And another customer walks in and says, "Where's the bathroom?" And the bar burns to the ground. So there's QA is as useful in the UI world, but maybe in a slightly different way than in the software world, right?
Yeah. Well, and I think there's most software tools that
backend, I guess.
Yeah, we're getting to the point where we let users pretty much just however they want to look at their data. We give them, they can customize their views, and at least for that sort of subset of applications, that's doable. But I agree. I think that's important. So we give
users infinite customizability in how they see their data, and we give them no customizability in the interfaces that they use to generate that customization of data visualization. Right? They're always the same menuing system. They're always the same look. They're always the same theme. You couldn't even make Visual Studio not look horrendous on your Mac until a year ago when they introduced it.
But the form follows function so much too. I wasn't involved in a lot of ERP system builds or deployments in my day, but I was with one, and they were, every little business, the cultural thing in the business ended up being a bolt-on to a whatever package they were using. It might have been Oracle Forms, actually.
Sure.
But the point being is that everyone has learned that does that for a living, that those bolt-ons are the biggest piece of technical debt you'll ever have in your life. They anchor you to the version. They prevent you from taking in improvements from the vendor, and they make support a nightmare, because when something doesn't work, you have to really unravel a lot of things to figure out what went wrong, and there's finger pointing at every step of the way. So customizability of UI, yeah, great, but at your own risk. I think about the apps on my phone. I can't really change the buttons and colors very much on apps on the phone, and it used to be a lot easier to do that on the desktop. I've noticed a lot less of that in just the base operating systems on the desktop. Even
take an iPhone. The only actual thing you can change is the background image.
Yeah, and they do that because if you're rolling out 500 million iPhones a year or whatever it is, you don't want everybody calling up with some stupid problem. Well, so that's the original question wasn't that. Your original question was who makes the decisions or how do these things get rolled out? And I just think it's I think it's not as good as it could be. There's too much of the field of dreams and not enough of those.
You're saying there's not a lot of oversight. The other thing is there peer review? Is there oversight? Is there staging, you get more money as you show results over time. Or maybe, yeah.
Make a proof of concept as fast as you can so we can pitch this to the next guy who's going to give us the money to keep it's almost like a venture capitalist type of build environment inside of in our world, inside a large organization, which is, can be kind of fun, but it can also be kind of brutal because in those worlds, 95% of projects fail in the VC world, and everyone's built on over-promising and lying through their teeth. So it doesn't make for a great culture if everybody's over-promising and lying through their teeth and then looking for the scapegoat. We had a joke the other day with someone. If you're assigned to a new project and you're not sure who the scapegoat is, it's probably you.
Yeah. The other thing is, like Peter Thiel in his book 0 to 1 talked about, that sort of design methodology, which is, build something simple and fast and dirt cheap, etc., versus like a more of a Steve Jobs, long-term, I'm going to build this phone. That doesn't mean he didn't have prototypes along the way, but he had
an idea of what it was going to be 5 years before it was a product. And
and I mean, he didn't ask us if that's what we wanted because frankly, we really had no idea, right? And now we're
we had a joke about that. If I'd have asked the people, or maybe it was Henry Ford, they said if I asked the people what they wanted, they would have said a faster horse.
Exactly.
I mean, yeah, right.
Never built right.
Well, and the horse and buggy industry was all up in arms, right?
Buggy whips.
Well, would you have gotten a Cray supercomputer? Remember the original Cray?
Yeah, same thing. Someone had to. So there's there's always the innovation, the single brilliant mind innovation happens.
But put a ton of money. It'll take a while. It's going to be something new and different. And so a company I'm very familiar with built a database appliance that integrated like the database software with all the various layers of hardware and sort of optimized all these internal protocols, did a lot of vertical optimizations across layers that you usually can't do that.
Oh, you're talking about Teradata?
No, it's actually
just kidding.
Although Teradata, but Teradata is another example. Actually, you didn't kid. I mean, it's actually exactly the same idea, right? So bottom line is, you end up with it's essentially like a SQL supercomputer. And but again, I think we're an outlier. You just don't see as much of that kind of, you see somebody like Google builds a search engine, a very unique kind of super scalable search engine. And then they have all their wood behind that arrow. That was a very unique product. It took them years and it's, they've continued to refine it. So again, that's interesting, but and I just think I think in corporate America, I think we talked about this. It's financially driven. It's generally short-term results, and so that you need like some kind of you need a Seymour Cray or a Steve Jobs or a Larry Ellison with really big, that find some way to have deep pockets and or Elon Musk, right? They can hold on for a long time and drive the development. So anyway, cool.
We call them moonshot projects sometimes. You've heard. Yeah. But if your company has 6 or 7 projects they're calling moonshots, they're probably not moonshots. They're probably quarterly thinking, short term. They just are trying to get a lot of attention, and they're caught up in that venture capital sales cycle of over-promising. So, let's call it a moonshot. Oh, good idea.
And honestly, if you are on a moonshot project, you're probably very, very aware of that. Because you have the attention of people that should not otherwise be paying attention to you, and it's very close attention, and it's heavily scrutinized. And
in a true venture capital world, too, failure means everybody loses their job and goes and finds another job. And enterprises aren't really well known for that. They just, there's a lot of safety in large enterprise.
Yeah, and there's minority. It's probably a minority view, but there's some old school venture capitalists like one of the Sun founders. I'm trying to remember his name.
Scott McNeely.
No, it's an Indian fellow. He he became a venture capitalist. I'll remember in a minute, but basically he pretty much took aim at this sort of like lean startup thing and said, look, you need a lot of money to get, if you're really going to have something differentiated, you typically
need money. You need resources to fund it to get.
Yeah. And
look at how that works. So even today, they don't go out and give you D-level funding on day one. They give you A-level funding on day one, which is enough to get you to the next tier. And then you got to kind of come back and re-justify yourself and show you've got customers and a future, and then you get B level funding and C level.
And I think what you're telling me is that's what you see in big enterprises today. That same kind of
It's not terribly different. That's true.
Yeah, and I mean, my feeling about venture capital is it should never have strayed from being a cottage industry, which is you had these sort of people with a unique skill set that just could spot stuff and adapt with the times and just weren't, because now it's essentially, it's primarily driven by MBAs and just very much, especially you get later stage, it's very financial. And
it's incredibly risky too. If you just look at the numbers, the number of failures versus successes, you need a really high multiplier on a success to make up for all the failures.
Yeah, you need
and they must get it because they're still doing it. They've been doing it for 30 years, so well, more than that probably. But
there's definitely like a practice to it, I mean, it's a learned thing, and you get better at it with time, right? So I think as a VC, nobody starts off with a big cachet of money unless you're, giving it to you. It's like you inherit it or something, right? Or you just start off wealthy. But if you're going to become a VC and you're not already a VC, you have to have a consistent line of successes to build that cachet, that war chest that lets you fund all those other ongoing things.
Unless you're Cerberus Capital, which you get like one big hog.
Yeah, right. Or something.
And you slowly lose their money over. But I say that a lot about Cerberus, they'll probably
You even though you have this high failure rate, you start to figure out what practices you can employ, pass or fail, that don't cost you much, right? That generally have a high degree of success, even if the overall idea doesn't have a high degree of success or just doesn't succeed, right? So you can go re-implement those things very quickly at the next 10 startups that you fund, right? Yeah. You have people that you can bring with you. You have ready-made processes to get up and running very quickly. So you can get right down to the act of, let's develop a thing and see if this sticks.
Yeah.
And that part does take time and money, but you can easily burn out and burn through a lot of funds if you don't have all of the rest of that stuff on tap, ready to go with a process behind it, so that you can just go right to the point, which is, who can I sell this to? Or will somebody invest in me because they believe in it, right? Yeah. So you have that high churn. Sure, you have a lot of turnover in VC, but if you're a VC that is not financially conservative with your money and tracking where it goes and how it gets spent, and you're just sort of like throwing it over, you're not going to be a VC for very long.
Yeah. And I think to your point about like the process, you even have folks like Y Combinator, and essentially not really VCs. They're more.
Y Combinator almost took that idea and like made a business out of it, right? To make it so consistent. Yeah.
But they're just playing the law of averages too. I mean, they're
right.
You get enough of them, and if your multiplier is high enough, then your failure rate is this. Yep. The math is algebra, not calculus. So
right.
Yeah, and then avoid obvious mistakes, and then I think they were good at that. So
cool. And coaching along the way, and I think incubators provide some things like, well, obviously space, but also human resources maybe, or higher. There's a certain number of things that an incubator doesn't want to get bogged down with.
Yeah. So that might be our next topic, which is this idea of like can you incubate new ideas? How do you create space and time to maybe push the envelope and not just build a quick thing in a vacuum. So
I learned everything I know by watching Silicon Valley. That's the only point I have.
That's right.
On DC, I never worked in it, so I couldn't. I can only describe what I've read and seen on TV.
That's right. Well,
very useful.
Yeah, well, very good. Well, we've done an hour, so I think we've covered a lot of ground here, and I think it's been enlightening to me.
It's always a pleasure.
Yeah, absolutely. So thanks for joining, and this will be up on YouTube and LinkedIn, and I'm getting in the process now of basically putting in a timeline. So I'll re-listen, put a timeline in, and then put a short blog post on what we talked about. So again, thank you again for joining, and thank you those in the audience who could join. And that's the end of the broadcast. Take care.
Thanks, everybody.
Ciao.
Yeah. Okay.